Okay, so today I want to begin a brand new unit of study. Of course, expect to continue to use the things we've been doing, which is using objects, reading files, getting input from the user, using Pygame, and using Turtle. Expect that to continue, but for this semester, we're going to shift. We're going to make a transition into a different paradigm called object oriented programming. So, the first question is, what is it? It's so common, it's even oftentimes referred to as just OOP. 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 It's a plan for developing a program. But it's more than just a plan. It's a style. But it's even more than a style. That's why I call it a paradigm. It affects everything about how you design your programs. Some languages are designed to support object-oriented programming. Some languages, such as Java, require it. And some languages are built with it. Python is thoroughly built in this world. So when we say I'm a Pythonista, I program in Python, people will think this person uses object-oriented programming. But Python is incredibly powerful and actually supports an entirely different paradigm called function. And function programming is kind of big hit right now. It's well beyond the scope of this course. In fact, I don't really cover it even in my Computer Science 4. We touch on it a little bit. But that's just, I always like to sell Python as a language for a lifetime of coding because it is so adaptable and usable. So it just, it makes sense. But we're going to be focused on object-oriented programming. To say that we're just starting this is kind of not true because we've been using this all along. Because in Python, everything is an object. Everything. In other languages, even in Java that requires object-oriented programming, not everything is an object. But in Python, everything. The number 5, the word true, the words that, the true, the Boolean true, a turtle, an actor, they're all objects. So now let's start talking. What is an object? Okay? Well, an object, and the reason why we call them that is because we like, the people who created object-oriented programming, they want programming and the way we talk about our programs to resemble the way that we interact with the world around us. Computers are extremely abstract machines, ones and zeros. How can we make sense of this? Well, let's think about you as a person, as an object. Okay? All right. But aren't you a soccer player? Well, that'll fix that. So an object has certain characteristics, okay, that are often called states because in the same way that a button can have a state of being on or off. But I'm going to call it characteristics. Now, these characteristics, those are things that are uniquely belonging to you. So I want you to think about what are the characteristics that you have as a person. Well, you have an age, maybe. And these are simple, but we could get much more complex, like personality traits, a history, a legacy, a memory, all sorts of stuff like that. Maybe you have a name, maybe a height, Oh, wait. And one of the brilliant things about object-oriented programming is once I design this object, I can always go back and add more characteristics later without breaking my code. But there's another thing that we're going to assign to objects, and those are called behaviors. They're usually called states and behaviors. But instead of behaviors, I'll tell you what. Let's call it actions. These are things you can do. What kind of things can you do? Well, you can walk. You can run. You can speak. Maybe eat or sleep. All sorts of things. The list could go on and on. We have all these things that you can do. So you have these characteristics that describe you, and you have these actions that you can do. And they all belong to you. Okay? So if you are, if you're me, we're used to having a variable age. And we'd say, okay, we can make a variable called age, and I can set it to my age. But the problem is, if I'm trying to describe myself, while I try and describe, say, when I try to describe you, I'll call you, Ryan, a student named Ryan. Well, I've already got Ryan. I've already got age, right? I can't, if I say age again and change it to like 17, well, then I've lost mine. But with object-oriented programming, we're not going to make a variable just called age. We're going to assign it to a person. So, I'm Jed, so I have a Jed.age. And Ryan might have a Ryan.age. And we can make as many of these different people, each one of them having their own age assigned to them. In the same way that we've written functions before. But when we called those functions, the entire program did it. So when we had just a walk function, if I called walk, then Jed would start walking, Ryan start walking, Tim, Jill, Susan, every single person I have, right? Because that's it. The entire program was walking. But now we're going to have Jed.walk, Ryan.walk. We've seen this already when we saw our turtles. We would make two different turtles and we gave them a name. And we can make one turtle move, and then we can make the other turtle move. That's the essence of object-oriented programming. Okay. Objects will interact with other objects through these actions. These are going to be called, now I've called them several different things, right? I've called them behaviors. I've called them characteristics. But I want to the characteristics we're going to call instance variables. Okay, instance variables. We've talked about variables before, now we have instance variables. And the behaviors, the actions are called methods. So a method is like a function, but it belongs to an object. So it's a method. An instance variable is just like a variable, but it belongs to an object. Another word for object is instance. So another word for an object is an instance. So that's why you could even call these object variables. Okay? All right. So that's kind of the whole idea. Let's see how we do this in our Python code. So we're going to open up Thonny. We're just going to make a new little assignment. All right, so let's make a new file. And I'm going to save it. And I'm going to call this file animals. And I really want to be emphasizing our naming strategies, okay? Okay, I made a new folder, called OOP or OOP unit. Let's do something like that. I want you to make a new folder for this unit that we're going to be studying so that you have all your stuff organized. We'll call it lowercase animals, okay? So in Python, the file is called a module. module. And they have lowercase letters. Later on in other languages, you'll learn that the files sometimes have capital letters. It just depends on how the structure is organized. But we're going to start with a lowercase letter file name. Okay, now what we're going to do is we're going to write what will be able to make an object. So we're going to create objects by making a class. So we're going to say class, and you'll notice it turns purple. Purple because it's a key word. We're going to be making a class dog. And we're going to define our dog by defining what's called a constructor. And the constructor in Python uses double underscore. So you see I've got the underscore, which is shift minus, and there's two of them. Okay? There's two of them. You'll have all sorts of problems if you don't have two of them. And then the parameter is the word self. And I'm going to describe my dog's breed, gender, and age. So I'm going to make my dog have a breed of a lab, a gender of a female, and an age of 2. So there's a lot of new syntax here that we're not familiar with, okay? For one thing, we've got these double underscore things. Whenever methods have a double underscore before and after them, they're actually usually called dunder methods. And I always make, for double under, I always think of The Office, Dunder Mifflin, right? But this is our constructor. The job of the constructor is to create the characteristics of our object. Okay, so we are ready to run this module. All right, we've run it. So we have the ability to make lots of different objects in Python. Everything is an object in Python. For example, a string. I know it's an object because if I press the period symbol and then tab, it should bring me up some help. And these are different things I can do. Like, for example, isUpper. It's a built-in method, right? This is because the string class is written for us. So that's just a reminder, everything's an object, but we're not doing that. We're making dogs right now. So I'm going to make this, I'm going to call this my dog. And here's how you create an object. You say the name of the class, which is class dog, open parentheses, and if you have something besides self in the constructor, you have to put it there. But we don't, so we just do that. And now we have an object. You have a dog that is existing in your computer right now. If you don't believe me, hit dog period tab. And look at that. I have an age, a breed, and a gender. The age is 2. The gender is female. And the age, let's see here, and the breed is lab. Let's see what happens if I say print my dog. Notice that my dog is a dog object at OX0421D 170. That is, and again, we're still waiting on some of that mathy stuff. We'll get to it eventually, but I want you just aware of it. That is a number written in base 16. Okay? And that is the address, the location of where our dog is being stored in our computer. Or at least it behaves kind of like that. That's why it says dog object at. This says main because we're in the main thread right now, but dog object at is what I'm talking about. So it is a real object. I'll tell you what, let's make another dog. I'll call it other dog. Now let's check out the other dog's age. Okay, well that's not that interesting. Why? Because that was the same age as my dog. Well, let's see what other dog.gender is. What do you think it'll be? It is, because we've already set them to always be that way, haven't we? We've made these things default variables. So are these dogs really the same dog? Does my dog equal other dog? False. They're not the same dog. They just happen to have the same characteristics out of the ones we've given it to it. Right? But watch this. I can say other dog. I can say print other dog. And you'll notice that my other dog is not the same dog. If they were the same dog, they would be at the same location. Now let's try this. How about other dog 2 gets assigned other dog? Now are they equal to each other? They are. I'm going to print other dog 2. Notice other dog 2 is the same location. If you're doing this with me, and I hope you are, you most likely have different numbers. I don't know. It'd probably be, it'd be kind of surprising if we got the same locations. So you should have different numbers, but however you print your other dog and other dog 2, they should be the same numbers. Okay? Because we just made another name for it. That might seem weird. It's like, how can other dog and other dog 2 be the same dog? Well, when we said other dog 2 is assigned the value other dog, all we did was give the dog object at 04300FD0 another name. I have multiple names. I'm called Mr. Wilshire at work, Jed by my friends, Dad by my kids, and I respond to all of them. Okay? So we can have multiple names. All right, let's check out another thing, though. We're not stuck, though, with these parameters. How about other dog 2? I'm going to say other dog.2. There's my breed. It's a lab, but I want to change it to a poodle. And I've changed it. So that variable, I'm not set with it. That's why it's called a variable. But the key is that it belonged to that other dog. For example, my dog was my other one. You'll notice that my dog.breed is still a lab. So here's a question to see if you've been paying attention. Here's other dog 2.breed. Remember, we changed it to a poodle. What about other dog.breed? Not other dog 2, other dog.breed. What do you think happened there? It's a poodle. Because that's just a different name of the same dog, isn't it? Very good, very good. Okay, so that's kind of our first little introduction. But what I don't like is that we don't have the ability to... I don't like that we have to start with the same dog every time, right? I would like it if we could instead make our dog have, different characteristics right when I make it. Does that make sense? No, I'm not stuck with this. I can always say other dog.age equals 3, and then, I don't have to be stuck with it. But it would be nice if I had an option to do it differently. Okay? So that's what we're going to do. We're going to add some customization. So what we do is we go here and we add some what are called parameters. Okay? So I'm going to call this B breed, or B, I'll say B, G, and A. And then I can say self.breed equals B, self.gender equals G, self.age equals A. And that works just fine. I can also even use the same word, because this breed here will be temporary, but then it changes its name here. So I can even do this. Okay? Oh, but I have to change it in both places. Now, that's going to change how I have to handle this, though, okay? Because watch now when I make a dog. Let me rerun this. So it's going to start this module over, clear that out. I'm going to make a dog. I'll call it dog1. To make a dog, we say the name of the class, and then we have to put some stuff in there. I wonder if I can get some help on that. There it is. Oh, never mind. That's all this. Okay, never mind. Sometimes some editors will bring up the list of things you have to supply it. Well, I need to supply it a breed. So I'm going to say bulldog, a gender, male, and an age 5. So notice, though, when you're used to matching the parameters in a function, but in a method, there's always one more because of the word self. So when you see that a method takes 4 things, remember the first thing is just itself. And self is just how it communicates. It separates it, makes it belong to it. Okay? And I forgot to put a comma. So, phooey on me. There it is. Okay. All right, now I got it. There's my little picture of how it works. And I can get my information. And I've got it all stored there just like I like. Now, let's make another dog. Dog2 is equal to dog. All right, well, that will be, let's see here, mutt, female, 3. And you can see that I have those different values assigned to that dog. Okay. All right. Okay, and so one last thing I want to go over with assigning characteristics, or what we call instance variables, is how to make it where they have a default value. Now, one of the rules about this is that if I make one of my variables what we call an optional variable, then I can't have another variable that's not optional after it, if that makes sense. So I'll show you that error in just a minute. So what if we wanted to make it to where we have some default values, that our default breed is a mutt, Our default gender is female, and our default age is 1. What that means is that now when I create a dog, I don't have to give it any parameters if I just want the default dog. Oops, I don't have a name yet. That's one of your assignments. Dog1.breed. Okay? So that's how we make default values for our constructor. Now, if we are going to do that, though, we might decide later on that it doesn't make sense to assume that all the dogs are female. So I might remove this here, okay? And then run it. But we're going to get this error, and it says non-default argument follows default argument, which is confusing. But what it means is an argument. Another word for argument is parameter, okay? So what it means is that one of these parameters or these arguments, this is non-default. It doesn't have a pre-assigned value, and it's after this one, which is not a problem. I don't have to make them all, but it's the rules in Python that the ones that you are not giving a default value to have to come first. So now that we've done that, we fixed the problem. So now when I create a dog, I'm not going to have the opportunity to do that anymore. Because you'll notice it's missing one, how many? Required positional argument. It's missing one required argument. So I need to supply that. We said that no, you have to tell me at least if it's a male or a female. Okay? But maybe my next dog, I want a little more customization. So I might say, well, this dog is a male. And this dog is a breed of poodle, and the age is 5. And you can see how that works, so that I am able to go back and actually change that. Okay? Okay, so then let's talk a little bit more about how we're creating dogs given these what are called positional arguments or positional parameters, and these default parameters, these optional parameters that we can set. So let's make another dog together. I'm going to call it, I don't know, dog 1 again or whatever. You can start over counting or something like that. And right now our dog is required a gender, is optional to supply a breed, it is optional to supply an age. Because these variables, though, are predefined, we can actually include them in our description. We can say gender equals female, like that. We can say breed equals boxer, maybe, or whatever. And age, is equal to 3, okay? And that works just fine. Now, so you might wonder, well, what's the advantage of that? Well, if I was to create a dog like this, and I just said female, 3, boxer, what I get is a very different situation. Because now look at the age of my dog 2. The age of my dog 2 is boxer. And that's because when I don't give it any keywords, these things here go based on what's called position. That's what they're called, positional arguments. The first variable after self is gender. The next variable is breed. So I gave my dog 2 a breed of 3. Does that make sense? Because it doesn't know. Earlier we put them down and we did them in order. But what if you're not sure what the order is? Well, that's what's so nice, though, is that when I put these keywords, I can do it. I can switch around the order. Okay. And then maybe, let's see here. Give me an age of 5. See, now I'm switching around the order, and I'll say breed. Give me another dog breed. Okay, yeah, like I can spell Chihuahua. All right, so that works fine. And then because it knows, even though it's a different order. So you can use the order that they're in, or you can use that. You can even mix the two, okay, like this. And then that's fine as well. So sometimes I gave the name, sometimes I didn't. But I can do this. I can put the non-optional variable back here if I want. And that works. But what I can't do is this. I can't put a positional argument without a keyword saying what it is after that. We saw that earlier. We have to have our our default, the ones that are optional because they already have a value stored in. Our default variables have to come after those. So it's perfectly fine to put your non-default variable after if you give it the keyword, but otherwise you have to face an order. So typically the way this goes is that if you want to supply the keywords in your arguments, great. If you don't, but don't really mix the two, okay? Because the position matters. Okay, so since we're going to be writing classes, the last thing I want to do is talk about how to test your class not in an interactive shell. We're going to need to see that in the exercises that you'll be turning in. So what I want you to do is define a function called main, okay? Notice it's just a function, not a method, because it doesn't have the word self in it. More on that later. And in here, this is where I want you to create your example dogs. For example, dog1 is equal to dog, and this is where I can give it my different information. Female, I'll just make that one default. Dog2, male, boxer 5. And what we can do is we can print out stuff like this. We can say dog1.gender, dog1.breed, dog1.age. And that works pretty okay. But I'm also going to ask you to write some better sentences. So the way that you would, let's say that I want to print out, this is a male dog or female dog. This is a male dog. It is this breed and it is this years old. So this is the way I'm going to do that. I'm going to say this is a, then I'll say str to make string. It is a string, but this is just good safety. You should string stuff. Dog1.gender dog plus, I want spaces there so they look nice and formatted. Maybe like that. It is a str dog1.age old, and then I'll put the breed. Okay, so that's how we would print out all that information. These are strings, so you want to make sure that when you add them, they're strings, or else it won't work right. And then we can do that again and I'll just break my own rules and copy and paste here. We can just change those and get a pretty good information. Now, if I run this code, nothing's going to happen yet because you have to tell it here to run main. You can see how that worked pretty good. It looks like I need a period at the end, right? Now I have to fix it in two places. That's why I don't copy and paste. Adding a period here at the end. But I want you to make it to where your code automatically runs. So at the very bottom of your program, we're going to add this little entry gateway. Say if underscore underscore name underscore underscore equals quote underscore underscore main. So if this is the thread that was run, then run the main function. Okay? So this is where, you can think of this as like a dividing line. Everything above this line is going to be all in classes, and then your little main tester stuff will be down here. Okay? And this could even be in a separate module. As long as it's in the same folder, this is fine. You could have these be in separate modules as long as they're saved in the same folder. We can use our dog class in a totally different file. It's fine, and we will do stuff like that. Okay, so that's going to be part of the turn-in process. So good luck.